Welcome. In this lecture, I'm going to do a little bit of a picture of what's happening with the partial derivative of f with respect to x. And you can really just kind of replace everything in it in order to figure out the picture for the partial derivative of f with respect to y. So I'm only going to do this one. And you have this kind of picture where you have, so I have some kind of function. So I have, this is going to be, let's just draw this. And this is like z equals f of xy. So, f is a two variable function in x and y. And so it's sitting at some height z, so we have something below it. And this is as in like, right, if I'm wanting to look at my x and my y coordinates, I have like, right, you can imagine that I have my x-axis and my y-axis down here. No, these look a little similar, but we're going to kind of deal with that. Actually, we're going to change this. This is going to be blue. There's something about no matter how many times you write and rewrite notes, there's always something that as you're doing it, you're like, I really wish I had done this instead. And this is, so we're just going to do that instead. We're just going to make that f of x. Y, it's going to be kind of blue here. Okay, so that's kind of the image of that so that it's distinct enough from that. I was a little worried it would be confusing when I looked at it now. And then we can have kind of a line here, right, which is we can fix a particular, right, if I'm taking the partial derivative of f with respect to x, I want to fix a y value, right? So maybe this is the line where, right, it intersects here at y naught. So this is the line y equals y naught. Okay, because I want to take the partial derivative at this point x naught, y naught, which is going to be sitting above here. So you can see, like, kind of if I went up, I have some kind of point here. Like, if I went up from the point, actually, I'm not going to want it right there. Let's just move it slightly off of here. So on here is a point. I have a point on here, which is like x naught, y naught. So this is x naught, and then y naught. Okay, and then I have that point on there, and then I want to go up from that and get a point up here, right? So the coordinates of this point are going to be, so this is going to be the point. So I have x naught. And then I have the point y naught, sorry, the coordinate y naught. And then that has to go into my function. So I get this z coordinate is going to be f of x naught, y naught. Okay, and then this curve here, so you can imagine I came up and I kind of sliced through here, and maybe this is going to kind of look like this. Okay, so this is going to be curved. This is what we get. So fixing, right, y equals y naught, right, i.e. kind of slicing along, i.e. slicing along the y equals y naught plane. Okay, gives this curve. Okay, so we get this kind of curve from, it's like I slice, I slice like this, and I'm slicing through this surface kind of floating there, and I kind of slice like this, and where I slice this surface gives me this kind of curve here, okay? And the slope at that particular point is going to be, so, and then maybe I'll just draw this like, so then if I actually took this, if I took the tangent line to this curve kind of floating there, right, so I would get, so this is what I get, this curve I get from that curve is that curve, but then this here is the tangent line, and this has slope that's going to equal this derivative with respect to x of x naught y naught. Okay, so let's go through this again, all of what I did, right? So we have our, z equals f of xy creates this kind of floating surface. And then if I'm interested in, and in there is this point, which is x naught, y naught, f of x naught, y naught. So once I determine my first two coordinates, I know the last one. So I get this point here. But the point x naught, y naught is a point that lives down here, right? You can think of this as where z equals 0. This is like the xy plane here where z equals 0. And then, so there's a point in here. I'm calling it x naught, y naught. Really, it's x naught, y naught, 0. And then I can look at kind of this line, y equals y naught here, and kind of lift that up, or you can imagine slicing with the plane y equals y naught, and that gives me some kind of curve in this surface I got by z equals f of xy, like the graph of that function. So I get this curve, and then there's going to be a tangent line to this curve there, and its slope is going to be that precise partial derivative. Okay? And because of this kind of whole picture and, what's going on, we know that. So d f, this is a little not dark enough for my liking. I'm just going to take this one. Okay, so we're going to say, so this partial derivative df dx at x naught, y naught this approximates right, what this is the change in, so this is, you think of this as the, well, maybe I'll just do it like this. So the change in f, no, actually, let's just do this like this. So the change in f divided by the change in x at this particular point, so at the point x naught, y naught, okay? So if I'm looking at here and I kind of go in the direction, so this is how does x change, right? How does the graph change as I change x? Okay, and because this is one of the things that I think confuses a lot of students is if I'm going along this line, I'm never changing y, but I'm changing x, right? And that's why we have to fix y, and then x is what actually changes as we move along this line. And the same thing is here is happening here. Like I'm moving along the graph of the function, but like my y, this coordinate is never changing. It always stays at y naught. It's x that's actually changing, okay? And that's how we're looking at how the graph or the height, right, in this here, changes as we change x and go in that direction. Okay, so I hope that made some sense, and I will see you in the next lecture.